Hey, hello, and welcome to the show. It's me, John Park, and it is time for another episode of John Park's Workshop. Thanks so much for stopping by. Let's see what's happening here. I want to, first of all, let you know that we'll be doing some audio things, switching between some mics and stuff. So if you can let me know if there's echoes, if there's sounds that are too loud and peaking out or so quiet you can't hear them, please let me know. I'll be keeping an eye over on the chat. Speaking of the chat, hello over in YouTube chat. Hello there, Charles Burniford and Dave Odessa, Johnny Bergdahl. Welcome. Thanks for joining us. If you are somewhere else like Facebook or Twitch or somewhere and you're wondering where the chat is, check out our Discord page, or our Discord server rather. You can head over to adafruit.it/Discord, jump into the live broadcast chat channel. And that's where things are happening. Oh yeah, I'm wearing this shirt. I just left it here and I picked it up. I'm going to take this off because this thing shimmers, has a thin stripe pattern and it shimmers like crazy. So before I walk over to the workbench where it really gets wild, I'm just going to drop that off right there. There we go. Yeah, that's why that was there. I was wondering, yeah, hey, shirt. I can throw that on. Mic volume lower than usual. Thank you. I'll goose that up a little bit there. Well, let's see, what else have we got going on? So, packed show today. I know I went kind of long last week. We won't be doing as deep a dive into something as we did with the setup on GP2040 CE for the Pico game controller stuff last week, so it won't be quite as long, but we will condense a bunch of what I think is neat stuff into the show here today. We've got I've got a coupon code for you so that you can save some money in the Adafruit store if you want to shop, get some stuff. I've got a recap of the Tuesday show, product pick. I have a CircuitPython Parsec for you that I think is a really cool one, and one I think I'm going to start using for certain types of projects quite a bit. I have got a cool software tool recommendation, and I have a retro gizmo to show you, something that might spawn some project in the future. And then I've also got a little bit of a Learn Guide recap. I won't go into too much depth, but I'll show you a couple of Learn Guides that came out recently. And then I've got this project that I'm working on, which is named right there, Wave Shape Faders. I showed off a demo of that last night on the Show and Tell with Liz. Thanks for hosting that, Liz, by the way. And today we'll get into a little more depth, a little more explanation, and I've got a nice visualizer we can listen to and watch a waveform change that'll help us understand how all this stuff works. And then we'll look at the simple example I have, as well as give you a preview of the 16 fader full bore project that I'll be building. Let's see what else is going on over in our chat. It looks like Johnny Bergdahl says they made a PR for one of the Adafruit Arduino libraries. Are there not Discord channels for that kind of development? Yeah, I don't know. I think we don't. I think we have just to help with Arduino, but we don't have an Arduino dev channel. That's a good question. Maybe ask around. Maybe ask that during Ask an Engineer, or over in the Help with Arduino channel. See if anyone wants to start up a help, or a dev channel for Arduino. That would be pretty cool. So let's see. First of all, I said I would give you a coupon code. This is our coupon code for the day: Wave Fader, Wave-Fader, or Wave-Fader. That will get you 10% off in the store today. Throw that in the coupon code slot when you are shopping. You can just go to adafruit.com. You can see we've got a nice little new products pop-up on the main page. There's also this drop-down menu here for products. Then you can click on New Products, View All, or just go to adafruit.com/new if you want to see what the latest stuff is. We have some pretty cool things here new in the store, but anything you want to get, pretty much, if it's a physical good. This doesn't work for certificates, gift certificates. It doesn't work for software or any kind of subscription services, but if it's a physical thing you can buy, throw it in your cart, and then on the way out, in the coupon code slot, type in Wave Fader, and that will get you a nice 10% off. There are some neat new things in the store. This one right here is actually what I'm going to be using in the project, not in this iteration of it, because I'm using a seesaw chip, but in the final, I'm going to use a couple of these to deal with my 16 faders, and you can check out some of the other new goodies here on the main page. And like I said, throw them in your cart, and then on the way out, type in that coupon code, and that will get you a pretty snazzy discount. Thin Man asks, what would you recommend for Windows PC synthesizer software? Well, if you are interested in sort of one page, enough knobs to deal with the fundamental stuff, I really like a free open source piece of synth software called Helm, H-E-L-M. A slightly more sophisticated synth that is by the same developer, also free and open source, pay what you like, but it's free and open source, is Vital, V-I-T-A-L, and that's the one I'm going to be showing today. If you want to deal with little modules and patch cables and fundamental stuff that you can turn into anything you like, VCV Rack also is free open source software, and I believe that runs on Windows, Mac, and Linux. And then there's a fork of it from a few years ago that'll run on iOS and maybe on Android. I'm not sure about that one. So those are worth checking out, Helm and Vital. So let's take a look now at the little 1-minute wrap-up. So Tuesday's show I do is a product pick show. I pick something from our store. Sometimes it's a new product, sometimes it's something that's an oldie but goodie that has recently become available again thanks to chip availability that was in short supply and has come looped back around. And that was the case this week with this product pick, the Pi Gamer. And here's a little 1-minute excerpt from the show for you to check out. The Pi Gamer. So this is a really great handheld platform for game development as well as development of things that you want to screen and some inputs on. It runs Arduino, it runs CircuitPython, and it's really great for Make Code Arcade. To develop games, you kind of need this big framework with lots of stuff ready to go, and Microsoft has really delivered on that to give you a really seamless experience setting up, learning how to create games, getting them onto your handheld. So I'll go ahead and turn this on, and you can see the little NeoPixels light up down there at the bottom. And it made a nice little sound. This is a game that I found that was in one of the Microsoft game jams. Oh, it allows you to stop time and throw a throwing star. Oh, and that guy's good. He doesn't want to get, all right. Huh, huh, huh. How about another one? Oh, I'm never going to beat that guy. Ah, he got me. Let's let him beat me. It is the Pi Gamer. It is indeed the Pi Gamer. Let's see, so moving on, let's dive into, actually I'm showing today's CircuitPython Parsec on a clue board, but it would work great on the Pi Gamer as well in the way I'm envisioning it, but it'll work on pretty much any CircuitPython board. So without further ado, let's check this out. Okay. For the CircuitPython Parsec today, I wanted to show you how you can use Supervisor to set the next code file. What does that mean? That means at startup, we can have a code.py running that is waiting for us to tell it a different program to run. So we can have multiple Pi files. They don't have to be named code.py. In fact, they can't be. They can be named pretty much anything you want. And at a press of a button, we can say, okay, let's go ahead and launch program A or program B. In this case, what I have is, you can see here, I'm actually, stand by 1 second. I just want to log my REPL into this board. Okay. Let's wait for this to start up. I'm going to reset it. Shoo away that mosquito. I don't know why it's not displaying in that REPL. You're gonna have to read this really tiny REPL. Let me zoom even closer in here and refocus. I was expecting to see some output there that I'm not getting. So I'm going to adjust this in real time. Okay. So what you can see on the screen here, the screen REPL is printing out for me. It says press A or B to run plantwaterer.py or code2.py. So if I press this A button, it will automatically reset the board, and now it's running a different Py file instead of code.py. It's running this clue project for the plant waterer. If I reset the board, it will go back to that original code.py file that is waiting for me to decide, hey, what do you want to run? So I'll go ahead and press the B button, and this time it's running a separate program. This one's called code2.py, and it's just printing out some text and the time in time monotonic. So the way this works is, let me go ahead and reset. The way this works is we're importing supervisor, and then I'm also importing board and keypad so that I can use the buttons here. I'm setting up the keypads. And then in the main loop, if I press a button, you can see here it says, if that button is the first button, button A, supervisor set next code file, and then the name of the .py file I want to run. If the other button gets pressed, then same sort of thing. Supervisor set next code file, code2.py. Then it will wait for me to release that button, lift off the button, and then it runs this supervisor reload. So the supervisor reload is different than pressing reset or power cycling. It has this notion of, oh, I've been told a different code file to run, and it will run with that until we either reset the board or power cycle it. So this is a really cool way that you can set up a menu type of system to run multiple different code files on your CircuitPython board. And that is how you can use supervisor set next file inside of CircuitPython. And that is your CircuitPython Parsec. All right. So I think that's super neat. And for some reason now it did decide to start printing out to the REPL. Will it not when I reset this one? I might need to give it a little time, a little pause there. Yeah, for some reason it doesn't print that message there. That's okay. But this is, like I was saying, this could be really good on boards that have a display in particular. You can also just remember which things you want to be able to launch on a particular device with some other kind of input for it. But really cool if you have sort of multiple different uses for a little gizmo like a Pygame or a Pybadge, and then you can use a button or other input to say, okay, let's run this program or that program or the other program. Let's see, Jeff asks in the chat, can you have the other programs return to the menu? It's a great question. I haven't tried that, but I believe you could insert this supervisor set next code file and supervisor reload in any of your code. So we could be running something, and as long as those buttons that we're using are sort of dedicated to that purpose, or key combos or something like that, I don't see why you couldn't say, okay, I want to relaunch, but this time into code.py and get back to that menu. Or have all the options available in every program. Seems plausible to me, but I haven't tried it. So yeah, really cool one. Thanks to Toddbot for suggesting this. He had a couple of tips on his tips and tricks page related to this notion of running a different program after you start up, which is really cool. Right, so let me disconnect that just so we don't have any conflicting code.py things happening. One other benefit to that, by the way, is as you know, if you're a long-time viewer, every once in a while I will save my code file, code.py file, onto my camera switcher, which is a little, I think it's a itsy bitsy, no, it's a Trinket M0 I have over there. Camera switcher is running CircuitPython. I have not bothered. I should add a little jumper and a boot text file so that it doesn't load as a CircuitPy drive, but currently it does. So every once in a while I overwrite the code.py file on there by accident. Be nice if the code.py file was just the supervisor thing as a protection measure. Okay, let's see. What else? I want to show in the Discord chat, P. Curry in a Hurry mentioned another virtual modular synthesizer plugin. I haven't heard of this one, but it's Distorho Cardinal virtual modular synthesizer plugin. So that might be worth checking out for people who want to get into virtual software synth type of stuff on their computer. All right, let's see. So what order should we do things in? I've got a few things to show. Let's start off with this retro Gizmo. I'm going to switch over to the bench here and ignore those bags of parts. That's not what I'm showing right now, but I'll move those off to the side. And I got a really cool old control box here that I think I'm going to try to turn into some sort of controller. You can see here it was a video production controller that was in some studios, Studio 5, no idea who, but a TV station probably. And this would have been the late 70s, early 80s. It is a controller for a Quantel DPE 5000. If you've heard of Quantel, it was probably the paint box, which came out in around 1981. And that really revolutionized digital effects in television, in live broadcasts in particular. This predates that. This was from 1978. This was a box that could do, essentially had a frame buffer. It could store some very limited number of frames of video in memory, and then it could be manipulated for things like scale, ratios, rotation. You could do picture-in-picture with the predecessor to this, so you probably could do it on this one, though I'm not sure. And if you look at the kinds of controls on here, there are some color controls for the border, so you could set a border around things if you were shrinking them down. And this allowed you to adjust the hue, luminance, saturation, and width, which I'm guessing is a uniform border size. You could turn this on and off, I guess is what this one did here. There were these really cool long joysticks here for adjusting the position of your video as well as the size of your video in a couple of axes. And then you could adjust what was happening. You could zoom in or out or not do either of those things, locking the ratio or adjusting the ratio, adjusting the width, adjusting the height, or I believe keeping them together. And then auto pan, I'm not sure how that would have worked within all this. There was keying, so I'm not sure if this was like a Luma key or a green screen or blue screen chroma key type of thing. Has a little momentary switch for turning that on and off, and then a couple of different effects and wiping and keying. And then there were some presets here. I'm not sure what those did, but look, it's our friends, the cool little steppy switches there. Let me zoom in on that a bit more. There we go. Looks like you could do a freeze. They had some digital noise reduction circuitry, which would have been particularly helpful for if you were scaling stuff and wanted to try to get rid of some of the noise. And then one of the really interesting things is, I believe these are 4 little bubble LED displays. So I think these are like 7-segment, 4-digit 7-segment or 4-character 7-segment displays that have the little lensing on top of them to make them look a little bigger than they are. It's tiny, tiny little LED elements. I think that's what those are in there, as you can see. So this came from Apex Sales, which is a surplus place, electronics place, and clearly someone either scavenged some parts out of this or used it as a prop and had it wired up in their own way, but I'll show you. It looks to me like maybe the board was just grabbed out of here for another unit. It has 3 of the 4 screws on top, so that's a start. And give me one second, I just wanted to pop open my chats so I can see if anyone has any questions or thoughts, or if my audio goes out. There we go. Okay. So this looks like it was built into maybe a sort of modular project box. I'm not sure if this was a custom box. I mean, it's got custom printing. Maybe these are custom cut holes here, but some of this looks like maybe a sort of a modular type of project enclosure thing. So I believe we're missing the control board. I'll leave that level of zoom, pretty tight zoom here, but there is one board remaining. A couple of chips have been swiped out of here. We have no connections to this connector here, so I'm not sure if that was an add-on that wasn't always in use or if that was meant to be plugged in, but I'm assuming that this was how it talked to the little, not so little actually, computer that was running this. Got some really nice wire lacing for this big bundle, beautifully made. You can see here's like a custom arrangement of this ribbon cable here running to some of the switches. Got some nice big XY joystick mounts here, 2 potentiometers per with springs. And they got some trimmer pots here with the big wheels on them. So some really cool parts there. It'll basically just have to all be rewired from scratch to use for something, but a really neat find. And a bit of, kind of cool because it's a bit of graphics history there with Quantel and their history. So looks like something got screwed. Yeah, look at this. We're missing a standoff, so this thing is a little listing up to one side there. But that is the Quantel DPE 5000. If you Google that, you will, and are interested in this stuff, you'll see some neat old ads and history of the device. I'd never heard of this one. Mostly I'd heard of things like the Henry and the paint box and slightly more modern stuff that was pretty instrumental in early graphics, computer graphics and broadcast graphics. So that is the cool retro Gizmo find, and maybe we'll revisit that. Maybe I'll put a Raspberry Pi Pico in there and run GP2040 or maybe a KB2040. We'll need some analog inputs for what do we need? 8 potentiometers. We got these 4 and these 4. So kind of a cool platform for something. And I don't feel too bad about giving it a new use because it's already been stripped of its original chips, so it's not really going to be usable. But there you go. That's the cool Gizmo find for today. All right, jumping back over here. Let's see, next up, what have we got? I wanted to do a little tool recommendation. So in the world of MIDI, there are a few applications that you'll run into when you're just trying to, on your computer, figure out what messages are being sent around your system. I often use MIDI, what the heck's it called? If I look it up, it'll, MIDI Monitor. And MIDI Monitor is nice. Actually, let me open it up and share MIDI Monitor to give you a understanding of why I like this new application. So let's go to, how about, put me over here. Give me a second, I'm going to make a new screen capture with a couple of applications on it. So here is MIDI Monitor. Hold on one moment. There we go. And I'll leave that there. And then I'm also going to add a second, let me scale this down a little bit. I'm going to add this second window. And this is the new app called Show MIDI that I wanted to share today. It's just released, free and open source. Okay, and Show MIDI, there you are. Okay. All right, so I'm going to hide Show MIDI off to the side for a second. Okay, so if you're looking here at MIDI monitor, I've got a little MIDI controller plugged in. And I am turning one knob on the MIDI controller. So what I'm learning right now is, okay, it is MIDI channel 2. It's a CC, continuous controller, control change, on channel 2. And the data it's sending out is, actually, what is that C there? That's not channel. I can't remember what that is. This is coming over, CC channel 103, 104, 105, 106. So I'm wiggling different knobs here, 107, 108. And the values it's sending are these in the 60s kind of values as I wiggle them. I think that's because I have this set right now as kind of a, I'm using these MIDI knobs as like little switches, little binary types of switches. If I press some of the, let's ignore the blarpy sounds there. If I press some of the buttons here, you'll see I've got MIDI notes being sent, as well as note on and note off messages, aftertouch. But the problem is, it's this big stream of info that is really kind of hard to pick through. If I'm playing multiple notes at once, they get lost. So right now I'm playing a chord. I've got 3 notes that I'm pressing. It gets lost in the shuffle here. So sometimes you have to just scroll back and look for something. So I found it very, very useful for a lot of things over the years, and I didn't really know what I was missing until this new app came on the scene. And I'm going to bring this into view now. This is Show MIDI. And I can leave them both up. You'll see, those should be able to see them both. So first of all, you'll see Show MIDI lists the 2 MIDI types of controllers, or MIDI possible controllers that I have plugged in right now. One is my camera switcher, which again, I haven't turned off the MIDI, USB MIDI capability on it, even though it's not being used in code. And the other is this Arturia Beat Step, this thing I'm using. I can just show you what I've been pressing. So this is the thing here. So now watch, when I go and twiddle knobs, you can see Show MIDI will briefly bring on, and as long as I'm adjusting it, it will bring on. So this is knob on CC112, and it shows the values that I'm sending. And then when I let go, it just kind of will fade away as I do other stuff. So here, as I'm playing notes, if I'm playing these chords, it actually just shows all 3 of those notes. And it's either a 0 or up to 127 of velocity as I press those. So really cool if you do MIDI stuff and sometimes are frustrated by a giant, endless, fast-moving stream of data going by. In fact, since this thing can act as a sequencer, if I hit play on it, you can see the difference, right? I am playing a few steps here, and as those steps get pressed over on my Show MIDI, you can kind of clearly see what's currently in play. Okay, those are the 4 notes that have been played recently. Trying to make that out in, and I don't mean to be mean to MIDI monitor, because I love it and it's been great over the years, but that is kind of how most of the MIDI monitoring programs I've used work, which is a log, a kind of streaming, scrolling log. So really nice, this Show MIDI. Let me show you where it comes from. Right here. I'll go ahead and stop this now and switch to this view. So this is by a developer named Geert Bevan, and I'm sorry if I'm mispronouncing the name, G Bevan. So this is github.com, G Bevan show MIDI. I'll just drop a link over in the chat right now. And this developer had previously made a couple of Python-based MIDI send and MIDI receive, or send MIDI and receive MIDI, which are really nice command line tools for, particularly during development, to just say, hey, I just need to, like, without hooking anything up, I just want to send a MIDI message from my keyboard from a command line interface. So those are terrific, really helpful for certain types of development. And this one is a beautiful new application that lets you see what's happening on a MIDI device or multiple MIDI devices without getting overwhelmed with data. So very cool. If you do MIDI stuff, you may want to check that out. Okay. So next up, let's get into this waveform fader, wave shape fader thing that I showed yesterday. So this is, I'll show you my current sort of prototype version of the idea, which is I got a microcontroller, I have some number of faders, slide potentiometers running to it through a analog to digital converter, and those values are adjusting the points of a single cycle waveform that is then being run at audio rates with different pitches through the synthesizer software, through Synthio inside of CircuitPython. So before I show that or where that's headed in hardware, I wanted to give a little bit of an example. And I'm going to turn off my noisy fan here just so I can hear a little better. I wanted to show an example of what the shape of the single cycle waveform is going to do to the character of the sound, to the way a sound, the sort of the tone, the timbre, the harmonics that we hear. These are the things we're going to be changing as we adjust the shape of one cycle of a waveform, which is then being repeated very, very many times a second so that we hear a pitch in the audible range. So let me bring Vital up here, and I'm going to turn up this amp and a microphone. Let me see if I can get it to make some sound. Now, if I can, I'm going to get it to play from my sequence here, and I'm just going to initialize this so that one tone goes away. And I'm going to add a few more notes. Okay, so this is playing right now with that waveform. That is the shape of one cycle of the waveform. I want to take a moment before I proceed to ask you if you can hear me and the synthesizer at the same time. I'm just going to wait for the chat to catch up because there's a little bit of a delay here, so sorry for the pause. Jeff says yes, so that's good, thank you. And let me know if you want one raised or lowered so that you can hear both me and that sound well enough. Since it's a tad loud, okay, so we're going to back that off, maybe like that. Okay, seems fine, good, okay. So what I'm going to do is I'm going to change this, I'm just going to pick a preset sine wave. Okay, so that's going to get quieter, and that's just the nature of a sine wave because it has just the fundamental tone. So whatever pitch I'm telling, if I tell it you're going to play a C, we're hearing just this smooth fundamental tone without many harmonic frequencies above or below that fundamental root note that we're playing. So the shape of that waveform really influences this a lot. So what I can do and this is Vital here, the program is named Vital. In Vital, we can go and draw the shape of the waveform. So now I've gone to sort of a triangle wave. It's not quite a perfect triangle. That's got a little bit more buzz to it than that sine wave, but not by much. It's just a slightly harsher version. So let's listen to a square wave. So square wave gets, again, even more character, more harmonics compared to the sine wave, compared to the triangle wave. Let's do, how about a sawtooth wave? Okay, so even more of that rich, buzzy, kind of metallic-y types of harmonics that you hear there. Let me see if I can shift the root note just so you don't get too bored of that. There we go. Now what we can do is start to draw arbitrary waveform shapes. And there's a lot of care taken in creating waveforms. Hard to do in analog circuitry, much easier to do in digital types of synthesis. And so you can see here, it's just a certain character to the sound. Notice small changes in the shape will make big changes to the sound. So watch this. All right, so something in that shape was causing those cool harmonics. And now it's kind of rounded up off the top end of that a little. All right, now we picked up a bunch of higher frequency stuff up there just by changing the shape of this waveform. Now, I'm going to pause this for a second, and I'm going to initialize that patch to get rid of that sound. In Synthio, we can do the same sorts of things. So we can say, I'm going to use a formula, an algorithm that creates a sine wave or triangle wave. There's certain waves that are easier to describe as a formula. And other shapes, these weird things I'm drawing here, we can input them as points in a table, essentially, sort of a lookup table. And I'll show you that in CircuitPython. But what that means is if I want to, in real time, adjust the shape of that with my 16 sliders, I'm going to be doing something like this. Sorry, one second. I'm going to reinitialize that again. Oh, it didn't make the terrible noise. Oh, good. Okay. So here in the Vital wave shape editor, I'm going to change this X grid to be 16. So that is what it'll look like to have 16 faders that I can adjust the waveform with. And then the number of points on Y, here it just only goes up to 16. I'll have a much, much larger range. As you know, as we read a potentiometer, a slide potentiometer, we might have 1,000 points, or 60,000 if it's a 16-bit, roughly. So this starts to approximate the amount of granularity you'll be able to do with faders adjusting those 16 points in our wavetable. think there's a mode, I don't know Vital that well, I think there's a mode where you can draw a little more. Yeah, okay, we just drag and draw. We don't have to be too careful about hitting the points. It'll interpolate it, sort of. Now keep in mind with this patch in the software, I'm not really doing much as far as filtering or adding any types of reverbs and effects, so this is really a dry sound, but it's the pure, just what can I do with the waveform, which is pretty interesting. So I'm going to turn the volume down on that for a moment, and let's now look at what this same sort of set of points looks like over in CircuitPython. So I'm going to jump over here and let me adjust what I've got in camera view here. I don't know if I'll use that MIDI controller. So let me just unplug that and set that down. Okay, so this is back to 4 points, essentially. A little focus there. And I'm going to plug just directly into this Metro RP2040 that I have here, and I'll talk a little bit about the microcontrollers and where this is going. So let's give this a USB-C cable. And I'm going to keep the sound off at first, and then we'll go and adjust some parameters and listen to it later. So in Sublime Text here, let me open up the CodePy file. There we go. So I've taken a Synthio example code from ToddBot, which is this 80s ARP Synthio. So this will play these little arpeggiations. And it's meant to be controlled from like a MIDI controller, so you press one note and it plays arpeggiations, little cute sets of notes as you move around. I'm just having it endlessly, sorry, I'm just having it endlessly play. I should have added some random to it, but it's just endlessly playing one arpeggio. The place where we get to adjust our single cycle waveform is right here. I have an object called Wave User, and this is a NumPy array with 4 points in it. So by default at startup they are just like that graph I was adjusting in Vital. Yeah, sorry, it's very quiet. I'm leaving that sound off. Actually, I'll turn it all the way down. Thank you, Andy. So I've got a point at 0, which is the center line. Then I have a point at basically the top, 64,000. Basically the bottom, 64,000. And then somewhere in the middle, 23,000. Or sorry, halfway between 0 and the top, roughly. So that array is what it's going to play at first. And I'll turn this sound up. So that's what that wave looks like. It's fairly saw-ish. Starts in the middle, it's up to the top, all the way to the bottom, and then a little. So the fact that we have this sort of mismatch between the last point and the first point helps to give us some of those kind of cool buzzy harmonics. But what we'll do now is start to adjust those points in sort of real time. It's not quite real time, I'll explain in a second. So let's go to something that's kind of a sort of sine wavy shaped. Or we can get kind of a triangle. And let me know again how that balance of sound is when you get a chance. Thank you. Here's a square wave. All right, so that cut some of those, and sorry, my amp here is peaking a little too, which is giving me some buzzing. Try to find a better gain. It's a little better. It's loud. Okay, thank you. Drop that down. My chat now says it's very quiet, and then 2 minutes later, loud. Right, so again, we've changed the character of that. In some ways, it's kind of like a filter, right? If you think of having a very rich harmonic sound and then use a low-pass filter or a high-pass filter to take some frequencies out, shaping the waveform has some similar results. But it's not quite the same effect of just kind of muting things above or below a point. It is instead really adjusting the shape of the wave. Now, if you think of these points as being how far away they are from a center line, you can adjust the amplitude and it gets really, really quiet, right? So this is just some like little sort of triangle wave that's happening right around the middle, and we can kind of add a peak to it. So that's as much as we can do with just the 4 points. But like you saw before in Vital, if I have a bigger table, if I have 16 points, now we can really get some interesting shapes to it. Love the Factory says, show an O-scope. Okay, this is a great point. I don't have one set up, but it's such a great segue to the inspiration for this project. So I'm going to jump back over to my browser here. This is a project by Mitsela? I don't know how to pronounce it, I'm sorry. Mitxela, who is an engineer, I believe, who builds some really amazing synthesizer projects and other projects that I've seen online over the years. And the idea here was to build what they called a hardware reverse oscilloscope. So if you look at the set of 16 sliders, let me find a lit up picture. There you go. Okay, so it's at an angle, but you can see here they're using some nice LED fader cap sliders. The positioning of the faders becomes the same as the oscilloscope view of the thing. So you almost don't need a display because you can see right in front of you the shape of that waveform. And they should, if you were to look at that with just a constant tone, with the period being just one cycle, then you would see a oscilloscope view that looks just like the arrangement of your faders, which is pretty cool. So shove them like this and you should see a square wave. And in fact, oh yeah, so there you can see this will be a nice saw wave that goes up, drops abruptly, and just keeps brrrring along. So this is the inspiration for the project, and they were doing, I believe, audio out, which is similar, which is the same we're going to do. They also had some control voltage CV in, so they could work this into a hardware, 4U hardware modular synthesizer that someone they know had. So this version that I'm doing is going to be much, much simpler, and it's just using CircuitPython and Synthio to generate either monophonic or polyphonic sound with a shaped waveform. Don't need filters and other things on it, going to keep it fairly simple. If you look, in fact, at, I would recommend, I'm going to put this in the comments if you're interested in this, I would recommend checking out the the project and the page. I'm just going to show some of their examples where you can see they also have a knob to say, okay, how many of these sliders are actually making up the single cycle waveform. So someone asked a question about how many points in the period. It, in this case, could be anything from 1 to 16. In mine, it's just been the 4, and in my final one, it'll be the 16. I don't plan to get as fancy. But there you can see the shape of that single cycle wave on the oscilloscope. It is going to match the shape of the faders there. As you can see, as they're playing notes on a MIDI keyboard, they're adjusting the fundamental, so it's going to move the thing around. But a single note just held should just look like your faders, which is pretty cool. So Jeff asks, you'll print the box. I'm not going to copy this project quite the same way. I'm going to do probably a PCB and a laser cut acrylic thing, but that you can 3D print those as layers if you want, or make an enclosure, whatever you like. So let me jump back over to the workbench for a second just to show you the main parts of this. So this is going to be one of these right here, actually 2 of these right here. So this is the ADS 7830. It is a 8-channel analog to digital converter. So I'll have 16 of my faders. So I'm going to have 2 of these. So I got a second one right here. So I have 2 of these. So these will be running over I2C to my microcontroller, which I believe is going to be either an Itsy Bitsy M4 or an Itsy Bitsy RP2040. And I'm planning to make the project so you can use either one. And that is so we can get audio directly out of the DAC. There's actually a stereo DAC on the Itsy Bitsy M4. We can send out over A0 and A1 and be able to then take that audio into other systems. I'm going to bring mine as audio into my modular synth and then be able to use effects and things on it. You could alternately with the RP2040 use I2S audio and plug an I2S audio amp into it and just go directly out to a speaker. That's an amplified speaker that'll sound nice and loud if you want to make a sort of self-contained box that makes sound. And here are the faders. There's going to be 16 of these guys. I'm going to keep it a little simpler and a little less expensive by not using the lit faders. Those are really cool, but I'm just going to use sort of these normal slide pots that don't have the extra pins necessary and cost necessary to have the lit up ends there. But I'm going to pack them in pretty close, almost just edge to edge, so it'll be a denser board than the sample I have over there for my 4 faders, because those have, I'm just using the little Neo sliders, so those have individual PCBs per. You can see here, these are quite far apart because there's little PCBs on each fader that are keeping those from butting up to each other. So this will be a bit more compact as a result, but there is a whole bunch of faders and fader caps right there. And then I'm going to use one of these TRRS breakouts to send the audio out over either a mono or stereo patch cable. I think it'll send mono without shorting the wrong things together, but I'll test that. But that's what the audio will come out, so that it can then go plugging into another powered speaker or amplifier or into a synthesizer, effects box, and so on. What else? So I've done a proof of concept of that design over in Fritzing that I wanted to show you. So here you can see I've got an Itsy Bitsy. I've got the A0 and A1 going out to left and right on my audio jack. I will probably add a little RC, resistor capacitor circuit here, just to denoise it a little bit, and that'll be particularly helpful if you are using the RP2040 and PWM out. That's a little aliased, so it likes to get a bit of smoothing on it. And then you can see here I've got those ADCs, 8 channels, and then a whole slew of slide pots here. This is what the schematic looks like. And I'm not going to be able to use this because that part there, that fader part, is not actually accurate to what the faders I'm using looks like, and I don't actually feel like making a fresh footprint or editing the footprint in fritzing because it's a little frustrating. So I'm going to rebuild this in KiCad. And while I'm at it, I think, as Lamore asked, if I could see if I could make it work with a socketed arrangement for the microcontroller, so that you can pick whether you want to have a RP2040 version or the M4 version in there, as well as I'll probably break out pins for I2S amp if you're using the version that can use that, and maybe some little jumpers that you can slice or put a little jumper shunt on to decide if you're just taking the DAC audio out to or the PWM or a DAC audio out to the audio jack, or if you're going to do maybe some screw terminal for the speaker. So that's my hope, is to make it kind of a nice little self-contained Gizmo, and then it'll be kind of a cool platform for writing your own unique Synthio synths, which can just use a USB MIDI to run the thing, or maybe it's generative, or you could maybe I'll put a classic serial MIDI on there as well, or you could kind of do non-music projects with it, because in the end of the day, it'll be a microcontroller with 16 faders on it. So I'll make the board available for you to print. It's not going to be an Adafruit product or anything like that. It'll just be something you can go and order online from JLC PCB or somewhere like that. So yeah, to answer Jeff's question, this will not be a product. This will just be a project and a learn guide, and something that you can riff off of if you want to. So that's my idea with that. That's where that's headed. Let me know if you've got any other questions in the chat. Let's see, Love the Factory asked, switch over the Discord here. Anything good for slow, like motion control, sub 1 hertz period? C. Grover said they've played with Synthio oscillator frequencies less than 0.01 hertz, so seems like you could use potentially use Synthio to generate those. Oh yeah, C. Grover said you could maybe say I'm going to use 12 of these faders for the wave shape and 4 for the envelope shaping, ADSR. There's a lot you could do with that. And I think there's a chance that Liz and I are talking about also making a provision for this to do control voltage and gate. So we'll collaborate on that, and I'll put the necessary traces and pins out to do. We have a 16-bit DAC that came out recently that might be a cool tool for sending out CV. And there's a really great playground. Let me show this post from C. Grover. Let's see, playground, C. Grover, on doing CV, your rack control voltage signal from Synthio. So this may be part of the plan here, and this is news maybe to C. Grover, but Liz and I were talking about with Lamore doing some CV out as sort of a secondary project, but again using just the one hardware design, if that makes sense. So if you want to check this out, I'll drop a link in the chat. Hope you don't mind, C. Grover, but there it is for everyone to check out. And you're welcome, Jeff. Jeff said, even I could understand. Well, if I can understand it and I can help you understand it, fantastic. let's see. Any other questions? Yeah, DJ MJR. Not too many parts. Yeah, this is a pretty. You can get away with pretty few parts, which is nice if you're using some of these breakout boards. You can get pretty minimal with it. You know, the fact that we can read in 8 analog ins on one of these little breakouts, and if you want to, and this is something I'll. If you look at my design here, I'm not using stemma QT cables because it doesn't need it. If we're on a PCB like this, we'll just slot those down in and solder them. But you could potentially run to stemma QT cables to different devices if you wanted to adjust how things work. So you can definitely prototype really quickly with the stemma QT cables, which is nice. All right, let me grab a sip of water. And Jeff asks, are there too many wires for clean sound on a prototype board? Sometimes on like a breadboard, that can get pretty noisy. We're not doing too much with audio in this circuit. The audio is kind of all happening on the microcontroller, and I'm then running it out to, you'll notice I put the audio out, the little TRS jack, pretty near the microcontroller. Audio circuits can be really tricky. They can get really noisy. There are things, I don't know much about it, but there are things that you can do to try to separate ground planes between audio things and power things, and filter stuff and put opto isolators. So there's a lot of things you can do to try to keep things from getting noisy. Sometimes just having things like NeoPixels on the board doing their thing can make your audio noisy. So yeah, it's one of the reasons I'm kind of keeping it simple. I think I'm resisting the temptation to add an OLED to it. So yes, audio stuff can get really noisy. On a PCB, we're probably better off than if we're doing this on a big breadboard with lots of wires everywhere. But it is always a consideration with audio stuff. So that's an excellent question. We'll see. Crossing fingers. We'll see how this comes. Let's see. I think that's going to do it. So thanks everyone for stopping by. This is our coupon code for today. I'll mention again, if you want to go to the store, pick up some cool stuff, throw it in your cart on the way out. Type that in, wave-fader. That will get you 10% off in the store. And we also have a bunch of freebies, so don't forget, if you want to know what they are, just go to adafruit.com/free, like I'm about to do now. And that will show you the deals we have. If you spend $99 or more, you'll get a PCB coaster. Very cool Adafruit logo PCB coaster, the gold variety. If you spend $149 or more, you'll get the coaster and you'll get a KB2040. If you spend $199 or more, you will get the coaster, the KB2040, free continental US ground shipping from UPS. And at $299 or more, you get the coaster, the KB2040, the free UPS ground shipping in the continental United States, and a Circuit Playground Express. So those are all perks if you spend a bunch. But no matter what, if you want to get stuff and save a little bit, you'll save 10% off today with that coupon code right there, wave-fader, wave-fader. All right, thanks everyone for stopping by. I'm going to sign off now. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Tune in all sorts of other days of the week for things like Deep Dives with Scott and Tim. We have 3D Hangouts on Wednesdays. I've got my Product Pick Show on Tuesdays. We have Show and Tell on Wednesday and Ask an Ear on Wednesday. And usually on Sunday, a Desk of Lady Ada at various hacker mom and dad times. So lots of stuff for you to come by and see. Just go to adafruit.com and click on the live link, and you will find out what is happening now. Thank you, everyone, for stopping by. I will see you next time. Have a good one. Bye-bye.